Lesson 69, Advanced Distributing. You already know how to distribute to get an x outside of parentheses, but one thing we should talk about is that sometimes distributing can cause an answer to have a power in it. Here's an example like that. See, here's x times the quantity x plus 2, and let's distribute this. What's x times x? Right. What about x times 2? That's right. And see, we end up with x squared plus 2x, which has a power in it. And here's another situation with powers where you have to distribute. See, this is x squared times the quantity x cubed minus 1. We've actually got two powers in this one. Let's distribute. What's x squared times x cubed? Exactly. And then next is x squared times 1. What does that equal? Good. And so we end up with x to the 5th minus x squared. And so the answer has two powers in it also. Some distributing problems can get even more complicated. Take a look at this one. See, this is the quantity x plus 2 times the quantity x plus 4. And we need to distribute here to get rid of the parentheses. One way to do it is to distribute this entire quantity x plus 2. We can just think of x plus 2 as one number, as a single number. And let's do that. See, we just take x plus 2 times x, and then we're multiplying the entire quantity x plus 2, so it has to have parentheses around it still. And I'm just putting the x in front of the parentheses. You know, that's the way we normally write something like this. And then next we multiply the quantity x plus 2 by the 4. And that gives us 4 times x plus 2. X plus 2 is still in parentheses. And then we have to add these because x and 4 are added up here. See, it's just like distributing, only instead of just distributing a single number or an x, we're distributing the entire quantity x plus 2. Only now what we have to do is distribute again in each of these. See, this is just more complicated. We need to take this x here and multiply it by the first x. What does x times x equal? Yes. And then now we take x times 2. What's that? You got it. And then over here we need to distribute the 4. What's 4 times x? Yes. And then 4 times 2, what does that equal? That's right. And now we have x squared plus 2x plus 4x plus 8. But then we can simplify some more because notice these two are like terms, 2x and 4x. Why don't you combine these? Good. And so we end up with x squared plus 6x plus 8. And this is fully simplified. So that's one way to handle this problem. You can distribute the entire quantity x plus 2, and then you need to keep going until everything's fully simplified. But it turns out there's actually a faster way to distribute in a situation like this. And to show you, let's go back to the original expression. And we call this advanced distributing because it works in complicated cases like this one, and also just because it's faster. But here's how advanced distributing works. Instead of distributing the entire quantity x plus 2 to the x and then to the 4, what we do is we distribute the x by itself, and then we distribute the 2 by itself, and then we add everything up. And let's just go through the whole process. We start with this x, and we're going to distribute this by itself, so we multiply it by this x here. What's x times x? Yes. And next we multiply the x by the 4. What does that equal? Right. And we add the x squared and the 4x. We're not done yet though, because now we have to distribute the 2. And so we multiply 2 by this x. What's 2 times x? You got it. And then now we multiply the 2 by this 4. What's 2 times 4? Yes. And these are added together. And so we end up with x squared plus 4x plus 2x plus 8. And then the last step is to combine the 4x and the 2x since they're like terms. Why don't you do that? Good. And so we end up with x squared plus 6x plus 8. And we know that this is right because this is the same thing we got before. But did you notice how much faster advanced distributing was? It didn't take nearly as long as when we distributed the entire quantity x plus 2. But the basic rule for advanced distributing, the way to do it is you just multiply each of the terms in the first parentheses by each of the terms in the second parentheses, and then you add everything up. Now, advanced distributing may seem a little weird, but it really shouldn't because you've actually been doing it for years. When you multiply numbers with long multiplication, in basic math, you're actually doing advanced distributing. And let me show you. Let's look at a simple multiplication problem, 13 times 12. Here it is all multiplied out. Now, the number 13 actually means 10 plus 3. The 1 stands for a 10, and then the number 12 actually means 10 plus 2. So when we multiply 13 and 12, we're actually multiplying 10 plus 3 and 10 plus 2. And then look at how we do it. We multiply 2 by both 1 and 3, and then we multiply the 1 from 12 by both 10 and 3. And then the last step is we add the results down here. But think about it. That's just advanced distributing. And we could actually multiply 13 and 12 using parentheses like this. See, we just write 13 as 10 plus 3 and 12 as 10 plus 2. And then all we do is multiply each of the numbers in the first parentheses by each of the numbers in the second. We multiply this first 10 by this 10 here, and then we multiply it by the 2. Here's 10 times 10, and then 10 times 2, and these are added. And next we multiply 3 by the 10 and the 2 in the second parentheses. Here's 3 times 10, and then 3 times 2, and then we add them. Now if we simplify this by multiplying everything out, here's what we get. 100 plus 20 plus 30 plus 6, and then the last step is to actually add. Why don't you do that? Add these numbers up. Good. And we end up with 156, which we know is correct. Now, that's not the fastest way to multiply 13 and 12, but the main point was just to show you that advanced distributing isn't really anything new. It's basically the same as multiplication. When you're multiplying plain numbers like 13 and 12, there are some shortcuts that you take, and you do it vertically. But when you're multiplying with x's, you have to do it the long way. And so that's why there's a slight difference between advanced distributing that you're learning now and the long multiplication that you learned in earlier math courses, but they're basically the same thing. And it turns out it's actually possible to multiply even longer expressions by advanced distributing, even longer expressions from algebra. Take a look at this one. See, this is pretty complicated, but all we have to do to advance distribute here is multiply every term in the first parentheses by every term in the second and add the results. That's the basic method for advanced distributing. Only whenever you're distributing something complicated like this that has a subtraction in it, it's best to change the subtraction to addition of the opposite before you start. So let's change this minus 5 right here to plus a negative 5. And notice I put brackets in because now we have parentheses within parentheses on the x plus negative 5. But let's go through the advanced distributing process. First, we're going to multiply this x by each of the terms over here in the second parentheses. First, there's x times x squared. What does that equal? Yes. And then next is x times 2x. What is this? Right. And now we do x times 1. What's that? Yes. And notice that everything's added. And then now we do the same thing for negative 5. We need to multiply negative 5 by every one of the terms over here. What's negative 5 times x squared? Right. What's negative 5 times 2x? You got it. And the last one is negative 5 times 1. What does this equal? That's it. Cool. We aren't totally finished because we still need to simplify our answer. There are some like terms here that we can combine. See, here's 2x squared and negative 5x squared. We can combine these. We could rearrange things so that these two are next to each other, so that the like terms are next to each other, but you can just imagine that in your head, I think, at this point. Let's just go ahead and combine these. Why don't you do it? What's 2x squared plus negative 5x? Awesome. Squared. And then actually there are two other like terms in this expression. See, x and negative 10x. These are like terms, and we can combine these. Why don't you go ahead? That's right. And so we end up with x cubed plus negative 3x squared plus negative 9x plus negative 5. And this is our final fully simplified answer. The main point is that no matter how many terms are inside parentheses, you can distribute by multiplying each of the terms in the first parentheses by each of the terms in the second parentheses, and then you add all of the results. But just make sure you change any subtractions to additions of the opposite first before you distribute.